Can I start now?
Give us just few minutes. It's about to start. The broadcast is about to start.
Okay.
Because I don't want anyone to be left out. So if they can't join on Zoom, they should go to YouTube.
Okay, no problem.
Sir, we can start the class now.
Okay. Yeah, good morning, class. Um, okay, I want to. Good morning, everyone. Please, I'm trying to share my screen, so that's what I've been. I'm trying to look for. Okay, today I will be teaching probability and probability. Now, please, can you hear me?
Yes, we can hear you.
Yes, sir. We
Sir,
can hear you,
clearly.
sir.
Yes, sir.
Okay, okay. Sorry, I will still share this my screen very soon. Now, but let me start. Like I said, FBA 242 is divided into two parts: the non-probability part and the probability part. And the non-probability part has to do with the data, mean, mode, median, range, variance, standard deviation, coefficient of skewness, coefficient of predation. That's the non-probability part. But I'm taking probability now because probability is also very, very important. I think probability take almost 55% of FBA 242 in a way. Because now, so, and probability is divided into, I'm dividing the probability into like three segments. I will divide the probability I'm taking, it will be divided into three or four segments. Now, the first segment will be general probability. Yeah, when I say general probability, how to what are the basic definitions? So I'll first give us the basic definitions in probability. So, uh, so we start with I would start with the basic definitions. Then from there we list that the first part will be has to do with basic definitions in probability. Then from that basic definition in probability, we link it to object of experiment. We take dice, coins, and maybe pack of cards. But I think I normally limit to dice and coins. So but I can introduce you to what when we talk of pack of cards. There's a material on that. So from there, we talk of relating probably to the counting system, that is the permutation and the combination. But we are not going to go in details in that one too. What is permutation? What is combination? We just know the difference between it and how to do small, simple permutation and combination. So, so like I said, so that is the first part. So let me go over it. I said the first part has to do with the main basic definitions in probability. Then link from those basic definitions, we link it to object of experiments such as dice, coins, and a pack of cards. Then from there, I will now introduce you to counting system in probability, and that has to do with permutation and combination. But like I said, I'm not going to go in details in that. So after that, we'll now talk of, so that's the first part. The second part will have to do with what we call random variables. Random variables as per probability. What is a random variable? So what do you understand by random? What are the basic? So so please, I don't want any interruption. Anybody that, please let us mute our mic, please. Please. So, like I said, in the second part will be all about random variables. So in random variables, we are going to consider the discrete case and the continuous case. But I'm not going to dwell into the continuous. I'm going to limit it to discrete. And what are we expect to learn in random variables? We learn how to find the expected value of the random variable, that's expectation. We learn how to find the variance of a random variable. We know how to find the standard deviation of a random variable, and know how to find coefficient of variation of a random variable. I said in the second part, is basically going to be, we focus on random variables. How do I identify, what do we mean by random variables? How to identify random variables? Then, like I said, random variables is divided into two. Discrete, we have the discrete case and we have the continuous case. But like I said, I'm not going to dwell in the continuous case. Basically, we're going to focus on the discrete case. So that's the second part. Then the third part of probability will be dealing with what we call the special probability distribution. I call it special probability distribution, in which we are going to consider 5 distributions. Let me go over it again. I said in the third part, we are going to consider 5 probability distributions, 5 special probability distribution. Now, we call it special. Now, this special probability distribution has a link with random variables. So if you understand random variables very well, then it's more or less like the application of random variable to real life problem. That is why so we now call that one special probability distribution. And what are these special probabilities that we're going to consider? Like I said, we're going to consider 5. We're going to consider the Bernoulli distributions. We are going to consider the Bernoulli distribution. We are going to consider the Bernoulli distribution, number 1. We are going to consider the binomial distribution, number 2. And we are going to consider that's number 1 is Bernoulli distribution. That is Bernoulli probability distribution. Number 2 is binomial probability distribution. Number 3 is Poisson probability distribution. Poisson probability distribution. Then number 4 is normal probability distribution. And the last one, which is related to number 4, is number 5, is special standard normal probability distribution. Now let me quickly go over it again. I said we have Bernoulli probability distribution, we have the binomial probability distribution, we have the Poisson probability distribution, we have the normal probability distribution, then we have the standard normal probability distribution. Now, I want to say something about this number, the third segment. Now, this third part, we involve us using what we call
better.
The third part, we involve us using for the third part. Now, the third part constitutes like 40 or 30% of what we are going to learn in probability. So what I'm saying is the first part, which has to do with the divination, is about maybe, let's say like 15%. Then the second part, which has to do with random variable, let's say that one is about 15% as well. That is out of 100. I'm trying to give you percentage on the topics. The first part is about 15%. The second part is about 15%. Now, the third part is about close to 40 or 45%. Or let me just say 50%. The The third part is about 50%. It means the third part is very, very important. That learning those 5 probability distribution. Then we are going to learn it with the help of what we call our statistical table. And I will employ many of us to get this table. And I said this table will help us through till we get to maybe year 4 or year 5. You have a course to make use of that table. It's a very important statistical table. And like I said, if you want the table, or if you want me to get the table for you, you can. I don't know how much they are selling it now, but I'll get the price. But you can just meet your governor and put down your names. Then I will be able to negotiate with the owner of the table. One of the course coordinator has the table, has a whole table. Or you can go to the bookshop, University of Lagos bookshop, and get the table. Because you will not have for that third part, the understanding of that third part depends on that table. And the table, like I said, is very, very important. Then the last part, so like I said, I've divided the probability into 4 equal parts. The fourth part, which is not that, the fourth part is more or less related to the third part. The fourth part is the relationship between this special probability distribution. Relationship. So it's all about relationship between the probability distribution. We want to look at what's the relationship between binomial and normal, Poisson and normal. Like I said, so we are going to focus on those 2 relationships. So if I want to give that one will be like 10%. That last part is more like 10% of what we need to learn in probability. So 10%, that's a relationship between binomial and normal, and Poisson and normal. Sorry, we are going to have 3 relationships, sort of. We have relationship between binomial and Poisson. That is, what's the relationship between binomial and Poisson? And when that, you see, let me just explain that. When we talk of relationship, there are some instances you have a binomial question, and the table of binomial will not be of help. So you now look at it, well, I can link this into what? Poisson. So that's what we mean by that relationship. How do you convert a Poisson problem, a binomial question to say? How do you convert a binomial to Poisson? How do you convert a binomial to normal? And how do you convert Poisson to normal? These are the 3 major relationships that we'll be discussing in that part 4. So part 4 is 10%, like I said. So let me go over something, then we start the part 1. So I said part 1 is the probability and introduction to probability, the definitions, the link it to the dice, the coins, then principle of counting, that is permutation and combination. Yes. So, and I said, now if I want to divide this something to percentage, let's say that one is 20%. Then is now I've changed it from 15 to 20%. Then the second part, which is the random variables. The random variables is all about how to convert a situation, how to model a situation, and you make it to how you convert a probability situation that you now make use of numbers. That's what I mean by random variable. By the time I get to random, I'll be able to explain that. So random variables is 20%. That is, in random variable, we learn how to, and like I said, there are 2 types of random variable, discrete and continuous. So, and we are going to learn how to find the expected value, the variance, the standard deviation, the coefficient of variation. So that one is also, that's 20%. So then the third part, which is the special probability distribution. The special probability distribution constitutes 50% of this probability. It means, now, let me tell you the implication of this. If I say something is, the first one is 20%, the second one is 20%, the third one is 50%, and the last one is 10%. It means if you are answering 10 questions on probability, let me just put this the analysis. If I'm giving 10 questions on probability, 2 will be from the first part, 2 will be from the second part, and 5 questions will be from the third part. Why 1 will just be from the last part? That is the implication of what I just explained now. I've divided my own probability into 4, and 1 constitutes 20%, the other one 20%, the third one 50%, and the last one 10%. So let's start with the first part. The first part is introduction to probability. Now, you see, to a layman, what do you understand by probability? Probability has to do with when you attach a level of confidence to happenings of an or occurrence of an event. Let me go right in that. I'm just giving you a layman definition of probability. It's not that a standard definition. We are still going to have a standard definition. But what do you understand by probability? The probability has to do with when you attach a frequency of or a degree of frequency to occurrence of an event. Let me give you an instance. If someone say, okay, there is 70% chance that rain will fall tomorrow, that person is telling you that the chances of rain falling, that is 70%, meaning that in probability, we always base everything over 100%. It's just like in exam, your score, every score is over 100%. And if somebody scores 70% in an exam, you know that person will get an A, meaning that that person has done brilliantly. So if somebody attach 70% to rain falling tomorrow, he's telling you directly that if you are going outside tomorrow, you should go along with your umbrella, because the chances of rain falling is very high. Now, another thing I want you all to know is that probability is more or less like when you base something on it, when you use percentage to express something. So most of the time, people always convince probability and percentage. In a way, if you are using percentage and you are relating percentage to event, indirectly you are talking of probability. So it means tomorrow, the chances of rain falling is very high. If somebody is 70%, 80%. But if somebody says, okay, the chances of rain falling tomorrow is 15 to 20%. So it is very slim. It means that probability of rain falling tomorrow is very low. So you may go out without your umbrella. That is the implication of that is rain may fall, and even if it's going to fall, it will not be much. So that's one thing about probability. Now let me relate it to business. Like a businessman now, you are a businessman, and you have two business proposals. You have business A and business B. So you go to the business analyst and say, okay, please, I want to invest in this business. They will now give you what are the probables, what are the they will look at the risk and the gains of in that business. Now they will now assure you, okay, if you invest in this business A, you have 75% chance of succeeding. Then that's okay. If you invest in business B, you have 50% chance of succeeding. Now, if you look at it now, as based on you knowing the concept of probability, now you now look at, okay, they are saying that business A is 75% and business B is 50%. So that means business B have an higher percentage, higher probability of succeeding than business B. So invariably, what you are trying to, what we are with that now, you can now conclude that out of the two business A and B, one will now look at it that business A should give us, since business A has a very high probability of succeeding, one should invest in business A. So what I'm trying to let you know that probability has to do with percentage of frequent degree of occurrence of an event, whereby when you attach percentage, when you attach degree to something happening or to an event happening, either the event is going to happen or not. So probability is more or less like, if I want to let you know, want to say it, probability is something that has to do with when you are attaching a degree to an unknown that is something that you don't know. You are attaching, okay, something that, okay, like I use an example of business now. That person wants to invest, he has not invested in that business. He's looking at it, he wants to invest in the business. And they are giving him the the prospect of the two business and saying, comparing A and B. And they are saying one has higher prospect than the other. So which means that person should invest in business A. He wants to make more profit. It's not that B will not give him a profit at all, but if you compare it, so one is 75, one is 60. So 75 is higher. So higher probability signify a higher chances of that thing succeeding or that event of happening. So now, so let's now define what are the basic, let me define the basic terms we use in probability. I think they're about I will divide these terms are probably, let me just say, they are more than 10, yeah? But let me see how many I can define today. Some we use our knowledge of FBA 110, our knowledge of set theory, to explain some of these terms in probability. But let me start with, now the first thing is we talk of what we call a random experiment. So I want to start defining each of these probability terms. What is a random experiment? So I will define, and I said, okay, so I want to define now. I said a random experiment is an experiment whose outcome cannot be predetermined. Let me go over it again. I said, what is a random experiment? A random experiment is an experiment whose outcome, whose is WHOXE, outcome is OUTCOME, cannot be predetermined. Predetermined is PRE-DETERMINED, predetermined. Any outcome, any experiment that involves you, that you cannot predetermine the outcome of that experiment, then that experiment is known as a what? A random. So one thing I want us to know, most of the experiments you have in probability is random experiment. So once you hear random experiment, just know that probability comes to mind. The word random is attached to probability. And something you cannot, when something happen as random, you don't have control over it. So something you don't have control, you cannot predetermine the outcome. So that is the definition of it. So I can use that one as a question in an exam. I can say an experiment whose outcome cannot be predetermined is known as what? Just know that the answer is a what? A random experiment. So a random experiment is an experiment whose outcomes cannot be predetermined. If I say, give me an example of that random experiment. Example are endless. You have a lot of examples around us. Let me give you those one. In a throne of a die, if I pick a throne of a fair die, when you say fair die, a die that has a head and a tail, two sides. If you toss a, I'm using die first before I use a coin. If you throw a die has 6 sides, and each side has an indicator 1, 2, 3, 4, 5, 6. A fair or an unbiased die. If I use the word fair, unbiased, we only use this word fair and unbiased as a result of the fact that in probability we want to be fair. We are dealing with fairness. We are dealing with something that is normal, because there's something we call gambler's die. If you know what we mean by people are into gambling, they have their own special die. They can have a die that all the 6 times we have the same number. So, but in probability, we are using the normal die. That's why we normally use this adjective fair or unbiased to qualify the object of experiment. So in this case, and as the example of a random experiment is a fair die, and we know that if I throw a die now, nobody can predict that. If you predict just maybe a mere coincidence, you may not be able. If I throw it now, you may not say. You can say one, and the actual something will be three that will show up. So any experiment you cannot predetermine the outcome is known as a random experiment. A thrown of a fair coin, I swear, a coin has head or tail. Now another experiment that during the olden days, there's another experiment that normally, even now going for an exam is a random experiment. It has to do with your, so random experiment, you want going for an exam, you either pass or fail. So that one cannot say predict I'm going to pass. It depends on level of your preparation. So if you prepare very well, definitely you now have what we call a side, and you are sure of passing that exam. But I just use that one. But the major something is when you talk of an experiment, you use an object of them like a coin, a die. In the only days, giving birth. In the only days, giving birth is a random experiment before the advent of scan and whatever. Only days are because it's until when the child is born you'll be able to know the gender, whether it's going to be a male or a female. So in the only days, random experiment, giving birth to a child is an example of a what? A random experiment. But now they can really, with the help of scan technology, they can even know the gender of the baby. They know everything about the baby using the modern technology. So uh, now that's number one. Number two is what we call so sample space. Another number two of our basic definition in probability is called, we have what we call sample space. What's a sample space? A sample space is all the possible outcomes. Let me just say, sample space is all possible outcomes of a random experiment. A sample space is all possible outcomes of a random experiment. That is, all the possible outcomes of a random experiment is known as a sample space. Like I said, in a throw of a die, let me an example of sample space. And normally, another thing I want us to know is sample space is always denoted by a capital letter X. We denote sample space with capital letter X. The S is as from the word sample. You know what the spelling of sample? So the capital S, the S that starts sample, the capital S of it. Sample space. Sample is spelled SAMPLE, and space is also spelled SPACE. Sample space. And say, what's a sample space? Just tell me the word. It's total possible outcome of a random experiment. The total possible outcome of a random experiment. So the key word there is that the possible outcome of random experiment. So if you don't mention random experiment, you are not talking of a sample space. So example of it is in a thrown of a die, the sample space are 1, 2, 3, 4, 5, 6. While for a coin is head or head, tail, or given birth to a child is either a male or a female, or you use boy, girl, anyone you want to use. So all these are examples of sample space, all the possible outcome. So after sample space, we now move to number 3. The third one is the event. What is an event? I'm talking of event. You know, event in the normal real world can be seminar, can be party, but in probability, what is the definition of an event? Because they can ask what's an event. Somebody will start defining the normal event. But in probability, there is a way we define event. An event is one of the most important aspects of probability. What's an event? So now we said an event. I want you to know an event is a subset. Let me go with that. An event is a subset. What do you mean by, let me spell subset? Subset is spelled SUBSET. Subset. An event is a subset of a sample space. Let me do it again. An event is a subset of a sample space governed. When you say governed, let me spell governed. 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 Governed by a specific rule. Specific rule. Rule as RULE. Let me go by the definition. I said an event is a subset of a sample space governed by a specific rule. An event is a subset of a sample space governed by a specific rule. So now, let me give you an example of an event. Like in a thrown of a die, and I say a die has 6. The total outcome of a die is 6. For the total outcome of a die, that is the sample space of a die is 6. We have 6 elements. I'll be using the terms of set. You know, in set there's what we call elements. So in a sample space for a die has 6 elements. 1, 2, 3, 4, 5, 6. So it has 6 elements. So now, if the question is, I want to now create an event from this sample, because we said something is a subset. When you say subset, the word subset means contained in from our knowledge of set. When you say something is a subset means everything you want to pick, it must be from that main set. It must be from the main event. It must be from that our main sample space. Like the sample space for a die, like I said, is 1, 2, 3, 4, 5, 6. So if I now want to define, I can say event of even numbers. Event of even numbers. Event of even numbers from a what? From a thrown of a die. A thrown of a fair die. So what I'm trying to say in essence is that in a die, what are even numbers? Even numbers are numbers that can be divisible by 2. We have the likes of 2, 4, 6, 8, 10, 12. Any number that 2 can divide is what we know as an even number. But now, I'm now referring to even numbers in a thrown of a die. So all you need to know that in a die, since a die has 6 elements, which is 1, 2, 3, 4. So in this now, if I say what are the events of even numbers from a thrown of a die, then the element of that will be 2, 4, 6. I will not go beyond 6 because the outcome of a die stop at 6. So you cannot go outside it. But we know that even numbers are many. But if we are being restricted, that's what we mean by subset of a sample space means. Meaning that is whatever you want to pick must be from your sample space. And the sample space in question is the one sample space for a thrown of a die, which is 1, 2, 3, 4, 5, 6. So now, so the thing is, so if I say what is the event of odd numbers? Event of odd numbers. You know that odd numbers are numbers that cannot be divisible by 2. So we have the likes of 1, 3, 5, 7, 9, 11. These are examples of, and so on. Example of odd number. But I'm still making reference to a thrown of a die. How many odd numbers do you have in a thrown of a die? It is 1, 3, 5. Just 3. 1, 3, 1, 3, 5. Why event of even numbers is 2, 4, 6.
4, 6, yeah.
So now, so we are through with event. That's an event. So event is always a subset of yours. You must have a sample space before you can talk of an event. So it means with event, without a sample space, you cannot define an event. So there must be a sample space before you can talk of an event. So maybe either the sample space is given or not, but they must make reference to a word, a sample space, before you can talk about an event. So number 4, we are going to the number 4 of our number 4 of the definition. I've defined 3. I've defined random experiment. I've defined sample space. I've defined event. I'm going to number 3 and number 4 now. Number 4 is called cardinality of an event. Cardinality. Cardinality is spelled Cardinality. Cardinality. Cardinality of an event. And we know now, another thing I want us to notice, I said sample space is denoted by capital letter X. Event is always denoted by capital letters. Note that. Event is always denoted by what? Capital letters. We can use capital letter A, capital letter B. Like now, if I want to denote event of even numbers now, since I know that even numbers start with letter E, I will use capital letter E to represent that event. If I want to say event of odd numbers, since I know that O starts odd is ODD, I can use capital letter O. So we make use of the letters of the alphabet. So we make use of every other letter except capital letter X, which is we use for sample space. Because if you use X to represent event, you are mixing, because X has been we have already ascribed letter X to sample space. So you cannot use capital letter S for event again. Although there's another notation we use for sample space, especially you use that notation. We call that notation in omega. Now, so all these things I'm saying, there's a material for it. I'm going to send the material.
Yes, sent.
So all these definitions, the explanation, we see all these notation. So all this, there's a material for it. So I was unable to share my screen. So you have seen all these definitions, the way it is, the presentation and everything. So there's a material. I will send it to you now. You see the now. So number 4, like I said, number 4 is cardinality of an event A. I'm using capital letter for the A. Now this thing is denoted by, when you say cardinality of an event A. Now let me define what cardinality means. Cardinality means the number of elements in event A. The number of elements in event A. The number of elements in event A. Now, another thing I want us to know, so that we don't mix this, we don't mix set with probability. Now, I will not want us to be using elements. Element is, we use elements for set, but just know that it's the same concept of element that we are using in the probability. But in probability, we call, instead of using the word element, we'll be using the word outcome. Although if we use element, that doesn't mean it's different, because like I said, set is very related to probability. So if you use element or use outcome, so number of outcomes or number of elements, so I'll be stroking them together. What I mean is element and outcomes are the same. So the element, so like I said, cardinality is the number of elements or outcomes in an event A, and it is denoted by, now let me explain how it is denoted. We have small letter N for Nigeria, small letter N. You start a bracket, then you put capital letter A, then you close the bracket. That is the notation. When you see small n, capital letter, opening bracket, capital letter A, what we are trying to say is we are talking of the cardinality of A, cardinality of event A. Now let me give you an example. like I said now, in the case of even numbers, or in a throne of a die, what are the outcome of that? We have 2, 4, 6. That is E equals to what? Curly bracket 2, 4, 6, close. You close the curly bracket. So that event is, if I now ask you what is the cardinality of that event, indirectly I'm telling you how many elements do you have in that set, and you tell me that is what? How many? Who can tell me how many elements do you have in the, how many outcomes? 3. That's correct. So it's 3. So you now say number n, small n, open bracket. Now, since our event is denoted by capital letter E, you now put capital letter E, close the bracket, then you now say it's equals to 4. Sorry, equals to 3, I mean. So that is, now let me give you another example. I want us to answer this question. Okay, now, what is the cardinality of event of odd prime numbers in a throne of a die? What is the cardinality? Let me go over it. I say, what is the cardinality of prime number? What's cardinality of event of prime numbers in a throne of a die? Okay, let me ask prime numbers. Now, the question you ask yourself is, okay, now I did not, let me go over this so that you see, in events, we use all these standard, even numbers, odd numbers, prime factors. We must know all these. What's the meaning of, what are the definition of this? So let me define prime numbers now. What are prime numbers? By definition, say prime numbers are numbers that can only be divisible by itself and 1. Number that no other number can divide it except the number itself and 1. Example of prime number. So who can tell me what's the first prime number?
Sir, 3.
3.
3.
Wow. Wow.
And
1,
everybody,
3, 5, 7, 9. Like that,
I
like that.
understand. You are wrong. 3 is not the first prime number. The first prime number, people always say 1. 1 is not a prime number.
It's 2. 2 is the first
The
prime number.
answer is 2.
3 is the first prime number. Now, so
you have missed it. So, but it's good that you corrected yourself. The first prime number is 2. First prime
Sir, how
number
is 2 prime number?
what number can divide 2 except 2 and 1? I like the question. Say, why is 2 a prime number? There's no any number that can divide 2 except the number and 1. That's the definition of a prime number. Can any other number divide 2?
No, sir.
So 2 is the, so take note, 2 is the first prime number, followed by 3, 5,
5, 7, 9.
11,
somebody
13.
mentioned 9. Listen, 9 is not a prime number. 3 can divide 9.
Divide.
After
9 is not a prime number.
yes, after 7 is 11,
11, 13, and 17.
17, 19,
19, 23,
29. So
77.
27 is not
37.
any number. 27 is not a prime number. 3 can divide 27, no.
But 37 is a prime number, right?
33.
Is it 37 or 27?
37,
Yeah,
37.
Yeah, it's a prime number.
33.
33 is not a prime number. 33. 3 can divide 33. Oh. So
Yes,
let's
sir.
limit any number that no other number can divide. So if I now ask you, what is the cardinality of a prime number in a throne of a die? You can see I've limited it. You know, we have mentioned almost 10 prime numbers now, but I'm now limiting it to a throne of a die. You now ask yourself, what are the outcomes? What is the sample space of a throne of a die? A die is 1, 2, 3, 4, 5, 6. Is that not?
6.
So
Yes,
It
sir.
So
is.
what numbers there? How many prime numbers? You have 2,
3
2,
prime
3.
2,
number.
and 5.
5.
So if I now ask you what's the cardinality, indirectly I'm telling you how many outcomes, how many of those numbers. So it is the answer will be 3. Do you understand? So they
Yes,
are
Yes,
sir.
sir.
only a prime number inside a throne of a in the sample space of a
Done.
die. So cardinality is more about the number of outcomes or number of elements in an event. So let me go to probability now. The probability of an event. That's the another term. Probability of an event. Probability of an event A. Mind you, the letter A I'm using is not small letter, it's capital, because anytime you talk of event must have a capital letter. I've said it. We use capital letter to denote an event. It's just a standard. You cannot use small letter to denote an event. So I want to define probability of an event. Probability of an event. What's the definition? How do you define probability? I'm not defining just probability, but I said probability of an event A. It goes together. What's the definition of probability of an event A? And it is denoted by P. This is it. Let me explain how do we denote this? It has a representation. We use capital letter P, open bracket, capital letter A, and close bracket. That's the denotion. I repeat, if you want to represent probability of an event A, it is denoted by capital letter
B. Open bracket.
P for Paul,
Yes.
P, capital letter P, open bracket,
Open bracket.
A, and close bracket. Once you see that, that means you are talking of probability of an event A. Now, and it's defined as, so let me define it. It's defined as the ratio, is defined as the ratio of, is defined as the ratio of number of elements in event A, is defined as the ratio of number of elements in event A. You can say I mentioned number of elements. Another word, I can use cardinality to represent that. Number of elements in event A. That is cardinality of A. Let me go over the definition. I said the probability of an event A is the ratio of number of elements in A. That is cardinality of A to number of elements in the sample space. To number of elements in the sample space. That is cardinality of the sample space. So if I say define what is a probability of an element of an event A, probability of any event, it can be A, we just use A, it can be any event. So probability of an event A, so I'm only using A as an example. So as to make the definition straightforward, is the ratio of the number of elements in that event, which is A, that is cardinality of A, to number of elements in the sample space, that is the cardinality of the sample space. Now, if I want to write it mathematically, I want us to listen to this. If I want to write it mathematically, like I said, everything you can say. As I'm saying it, since you are not seeing it, you may not, but I will send the material. By the time you look at the material, you understand it better. It's denoted by capital letter P. I'm writing it. So just be writing if you want to take it down. Capital letter P, open bracket, capital letter A, close the bracket. You now say equals to, you put your equals to sign. You now write small n, small letter N, Nigeria, small letter N, open bracket A, capital letter A, and close the bracket. you now put division line under that n capital letter. You put a line under it, like you are using division over. That's over means division line. Then under that, you now write small n again, open bracket, capital letter X. That X signifies sample space. Then close the bracket. That is, we are talking of P of A equals to N of A divided by N of X. That's the definition of probability of an event. So I can use that question. I can just say define probability of an event. So I'll just give the option A. N of A over N of B, N of A over N of X, N of A over N of C. So, and you should know that N of A is over N of X. That is the definition of probability of an event. So now let me give you an example on how to. I'll use the event of to explain further. I will use the event of die and a coin. Let me use a coin and a die now. For other example, you see it in the material. That is, I can use 2 dice. I can use 2 coins to illustrate. But for now, let's use 1 die and 1 coin. Now, if I say the question, this is how a question on it. If I want to ask a question, so I want to use this, a die. So I'm using a die as my object. I'm focusing on the die now. So let's do 1 question on die and see if we can round up the class. Now, the question is this. What is the probability of obtaining? You can write. What's the probability, or you can just, what's probability of obtaining a even prime number? Listen, what's the probability of obtaining what's probability of obtaining an even prime number in a throne of a die? I repeat, what is the probability of obtaining an even prime number in a throne of a die? Now, the solution. If you want to answer a question of probability, the first thing is you ask yourself, what's the object of experiment we are dealing with? And we are using a die. Is that not? So the first thing is you have to first write your sample space. And our sample space, which is capital letter S, is equals to, you write your curly bracket 1, 2, 3, 4, 5, 6. You use the curly bracket to close it. Note, I want you to note this. You know, in mathematics, we have like 3 types or 4 types of brackets. Note, anytime I say open bracket, close bracket, I'm talking of the half bracket, the one that looks like circle. But if I'm listing an element, if I'm listing a set, like I'm saying sample space, we use the coily bracket, the one that looks like a coil. I hope you understand, because in that we have done that one in set theory. The difference between using in set, we use coily bracket. So like I said, event, sample space, they are set in nature. So we also use coily bracket to present them. So like I want to write my sample space now. I will say my sample space, capital letter S, is coily bracket 1, 2, 3, 4, 5, 6. I close the bracket. So what I'm saying, I've listed the sample space for a die. The reason why I listed, because my question is focused on a die. Now, and I said, we always find probability of an event. Now the question is, in this question now, you now look at what is the event in this question. Who can tell me what's the event in this question? What is it? I want somebody to answer me. What's the event in this question? The question I'm about to solve now. What is the event? I've mentioned that our object of experiment is a die. That's why I listed the sample space. But in the question, what is the event what's the event?
The event is 1, 2, the numbers, the elements, sir.
No. Let me read the question. So you see, Now, you see, that's one thing I want us to know. You see, in any probability question, there are two major things in a probability question. So if you don't understand that, you will not be able to answer any probability question, a direct question as I've given you now. Let me go over the question and say, what is the probability? You can listen. What you will see a probability. If it's a probability question, you will see a probability. I said, what is the probability of obtaining, I hope you again, of obtaining an even prime number in a thrown of a die? I don't know whether you get the question. Let me repeat. I said, what's the probability of obtaining an even prime number in a thrown of a die? So in this question now, the die is our object of experiment, which is our focus, which is our reference object of experiment. So
2, 6, and 4.
Hello? The event here is, let me show that I'm just, so in this question now, what probability are we trying to obtain? We are trying to obtain the probability of what? Even number. So that's what I'm asking. So you must be able to know the event and be able to relate it to the object of experiment. If once you are unable to do, then you'll not be able to answer the question correctly. So you have to do this. So when you are solving a probability question, you do it in a matter of seconds. You do this analysis. My object of experiment is a die, and the die has 6 outcomes. You write all the outcomes. But my object of experiment is what? Even prime number. You now ask yourself, I've already said what are prime numbers? Prime numbers are 2, 3, 4. But they are now telling you the even, and you know that in a die, there are 3 prime numbers. 2, 3, 5. But they are not telling you to. If the question has been, what's probability of obtaining a prime number, is different from an even prime number. I want you to understand these two questions. People always mix it up. Even prime number, they are saying, out of all the prime numbers in a die, which one is even among them? Who can tell me what's the even prime? 2, exactly. So that's correct. So 2, it means it's only 1, it's only 2. So if I'm going to write, if I want to represent my even prime number, I will use capital letter E to represent that my even prime number. So I will use capital letter E. So if I'm going to write it, I will say capital letter E equals to, I will open a curly bracket. I will only put 2 inside it. Meaning that if I ask you, how many elements do you have in your even prime number? How many elements?
3 elements. One.
We're saying 3 again. In this question, we are saying even prime numbers, and we only have 1 even prime number, which is 2.
Yes.
So it's only, so we only having 1 word number. So and so if I ask you, what's the probability of E will be what? 6. Is that not?
Come again, sir.
Number of elements in our sample is 6, and number of elements in our prime number is now 1. So based on the definition of probability, says the number of elements divided by the number of sample space. So the answer to this question will be 1/6. The answer will be what? 1/6. That's the answer. So if I say what is the probability of obtaining an even prime number in a thrown of a die is 1/6. Now let me ask this question. I want everybody to make an attempt. What's the probability of getting? What's the probability of either you getting or obtaining is the same thing. What's the probability of obtaining a prime number in a thrown of a die? What's the probability of obtaining a prime number in a thrown of a die?
3/6.
3/6 divided, that's 1/3.
1/6 is 3/6, but you may not see this in the option.
1/2.
But as you have said, 3/6 is correct. But you may not see 3. So, but you see 1/2 in the option. So
Okay.
1. So
Okay.
answer should be 2/6. But we normally express our probability in the simplest form. Simplest form is we look at whether there's a common factor, something that is common to both numerator and denominator. Since 3 is common, you simply divide 3 1, 3 divide 6 2. That's why it's 1/2. So in the option, you look for 1/2. Let me ask you another question again, because it's good for you to. What probability of obtaining number greater than 4?
Number
2/6.
greater than 2/6.
What?
6.
Wait. I don't want one person to be answering the question. Now,
One
if I
over
say,
three.
I know. Let me go. I said the question was probability of obtaining number greater than 4,
2/6.
2/6,
which is 1 over.
2/6.
which is 1/6.
1
Three
over
is
3. 1
1
over
over
3.
3.
1/3.
Yeah, that's correct. Yeah, that's correct. So what we are saying is, hey, let me explain. The answer is 2/6, which is 1/3. So 1/3 is the correct answer. And when I say now, let me explain the question. Say, what's the probability of obtaining a number greater than 4 in the thrown of a die? Already a die has 6 outcomes. Now, out of these 6 outcomes, what are numbers greater than 4? It's just 5
Can do
and
that
6.
cooking.
It's just 5 and 6. It's just what? 5 and 6. Do you understand what I'm trying to say? It's just 5 and 6. So, and 5 and 6, how many outcomes is there? There are just 2. So that's why the answer will be 2/6. Now, let me go to a coin now. For a coin, let me use an example on a coin. I want to round up the class. I have something to do by 12:30. But like I said, all these things we have done today, you definitely see them in the material I'm going to send. But probability, like I said, probability
Go and
is
carry
wide.
garlic and ginger and chew. Go and put hot water, put garlic, put ginger, squeeze that lemon
Hello,
in it and put honey and drink.
Mute your mic.
sorry, mute your mic. Now, what I'm saying is this: probability
No.
is wide. But we are going to see how this
And you
this
put
person.
honey. That's fine. Okay.
Which is,
Madam, kindly mute your mic now. Kílódé?
you are in a class, please. I know maybe just try. Let's just now, because there's no way I'll be talking, you two be talking. It will not make sense. So now, okay. So what I'm saying is, probability is wide, but they are simple and straightforward concepts if one understand the rudimentary involving probability. Like I've given you an example now, and you are immediately you're able to answer the question. So once you have a question on probability, the first thing you ask yourself is, what's the object of experiment? So what object are we using? So is it a die? Is it a coin? Like I said, I will only give you the skeleton of card, but I don't normally give question on cards, but you can have an idea of what card is. But we are focusing mostly on die and coin. But I can give you question now. Now going back to, in the case of a die, let's go back to die now. I've used example of a die, one die. Now, if I now ask you, what is the cardinality of the sample space of throwing a die? What is the cardinality of throwing a die? What's the cardinality of event of throwing a die? Indirectly, I'm asking you, what's the number of elements in the sample space of throwing a die? And we already know that in throwing a die, it has 6 sides. And that means the number of elements in it will be what? 6. Do you agree with that? Now, if I now ask you, probability, what's the cardinality of throwing what's the cardinality of the event of throwing two dice together? Either you say event of throwing two dice together or throwing a die twice. Please take note of this. If I say tossing a die, two dice together, is the same thing as throwing a die two times, twice. The outcome you get when you toss two dice together is the same outcome of throwing two dice twice. So please take note. They can use that word. Either you say two dice are tossed together or tossing a die twice is the same thing. So now the question is, how do we know this outcome? There is a formula for it. The formula is it's not just formula, but let me just, anytime you want to find the number of sample space, that is the cardinality of sample space. Let me use that one. Cardinality of sample space of throwing a die twice or tossing two dice at the same time is the how many sides do a die have? 6, as we know, as we said, 6. Is that not? Then you raise it to the power of the number of times or the number of dice you are using. Like this now, this example, I say you are using 2 dice. Is that not? It will be 6 raised to power 2. And what is 6 raised to power 2? 6 raised to power 2 is interpreted as 6 times 6. So if you multiply 6 times 6, it will give you what? 36. That's why if you toss a die, you are going to get 36 outcomes.
6 times 6.
Now, that's 6 times 6. Now, let me give you a question from one of the last year exam. The question is, what's the cardinality of tossing a die? What's the cardinality of the sample space of tossing a die? Thrice. 3 times. Who can tell me what's the answer? Tossing a die thrice. What's the cardinality of the sample space of tossing a die thrice?
That would be 6 raised to power
2. 6
That's
times
6
6 times 6.
raised to power what?
3. 6
216.
times 6 times
6 raised to
6.
power 3.
216.
Now, even
That is 216.
that's 216, correct? That's excellent. It's 216. That's one of the questions of last day. The question is, what's the number? They can just say what's the number of sample space when you toss a die, when you throw a die thrice, it's 6 raised to power 3. If it is 4 times, it's 6 raised to power 4. If it is 5 times, it's 6 raised to power 4, and so on. So now for a coin, a coin has how many sides? Two sides.
2 sides.
Is that that's 2
Yes, sir.
sides? If I say what's probability of tossing a coin twice, it will be 2 because the total number of sides is 2. Number of times you use it is always the power. So take note. You know, in the case of die, we use 6 because 6 is the number of sides for any die. But a coin has 2 sides. So if I say what's probability of tossing a coin twice, it will be 2 raised to power 2. And 2 raised to power 2 times 2, which is 4. What's the probability of tossing a coin 3 times? It will be 2 raised to power 3, which is 2 times 2 times 2. That's what? 8. Now let me ask this question. What's the cardinality of a sample space of tossing a coin 5 times?
2 raised to power 5.
Well, what's the answer?
2
2
times
raised
2.
to not 2 times 5, because in the option that year I put 10. Some people pick 10. They thought 2 raised to power 5 is 2 times 5. 2 times 5 is not 2 raised to power 5 times 5.
32,
It's
sir.
32. Yes, correct. So please take note of all this. So I want to round up. I say I'm rounding up by 12:30. I'm sorry, I will have continued, but I have some other things to do. What I would, so you see, with this now, I will try and see how, if we'll be having more of this virtual class. If you see, as me, I have the material, we will have gone far, because I will just be reading through the material, explaining the solutions and every other thing. So we'll be having more of this virtual class. I will discuss with Ruth, so we will organize more of this. because we have limited time, and I want us to cover a lot in this probability. And from there are a lot of questions in a class. I'll try as much as to solve like 10, 20 questions. Like in the matter of how many things, we solve like 10 or 8 questions in a way, because the definitions I've given, they are questions on their own. Like I said, if I say, okay, let me ask this question: an experiment whose outcome cannot be predetermined is known as what? Who can tell me? An experiment whose outcome cannot be predetermined is known as
Random
what?
experiment. Random
Explain.
experiment.
Experiment is one of last year questions.
Random experiment.
Random experiment.
Correct. So that's what I also, if you understand, if once I send the material and you're able to relate with it, you solve as many questions as possible. So probability is not that difficult. So it's only when you have the basic understanding. So I'll be rounding up. So I will see you some other time. So please bear with me.
Thank you, sir.
Thank you so much, sir.
Thank you, sir.
God bless you.
Thank
Have a
you,
blessed
sir.
weekend.
Thank you, sir.
Thank you,
Appreciate
sir.
You're welcome. Thank you. Wish you the same.
You are the best, sir.
Yeah, thank you. Thank you.